In this video, we're going to talk about the types of graphs we can make to look at just a single variable at a time. It turns out that the type of graph we'll get back from qplots will depend on the nature of the data in that variable. If we have a continuous variable, qplot will generate a type of graph called a histogram. Whereas if we have a categorical variable, like say species, the species of hawk, then we'll get a bar graph like we see on the right here. So the histogram that we get for continuous variables divides the x-axis up into ranges called bins, and then it counts how many observations fall into each bin. For example, here's a histogram of the wing variable from the Hawks dataset. And what's happened is we've divided up the range of wing lengths on the x-axis here into a number of bins, right? The width of each one of these bars, each bin, goes from a certain wing length up to an upper wing length. And then we say, well, how many hawks fall within that range? Okay. And to make things a bit clearer, I have added a layer to this graph that shows a dot for each hawk on top of each bin of the histogram. So we can see, for example, that this first bin on the left, right, is one count high, and that's because one hawk has a wing length in the range of this bin. The next bin has two hawks that have a wing length in this range. The third bin has no hawks that had a wing length measured in that range, so its height is 0. So the y-axis, we don't actually supply a variable to the y-axis. This is generated for us automatically by counting up how many observations fall into the range of each bin. We can change the appearance of a histogram by changing how many bins we divide the x-axis up into. So we can either set the number of bins, in which case the width of each bin will be determined for us, or we can set the width of each bin, in which case it will figure out how many bins it needs in total, right? So you can either set the number of bins or the width of each bins with the qplot function, and then the other one of those numbers will be determined for you automatically. So this top left graph, we have just two bins, right? And we see that most of the observations fall into this first bin, very few are falling into the second bin. The opposite scenario is down in the bottom right here, where we have a lot of bins. And we can see we've actually got kind of a jagged pattern here, right? Because just thanks to random noise, there's quite a bit of variation between neighboring bins in terms of how many observations fall into each bin. Perhaps the best histogram is this one here in the top right, where we have enough bins to get an idea of the shape or the pattern of the data, but not so many bins that we have this really sort of jagged pattern. Okay, so we've smoothed out the random variation, but we still get to see the sort of overall shape of the distribution. We call the shape of the distribution just the distribution of the variable. So if we have a categorical variable, then qplot will create a bar graph. And it's the same concept as a histogram, right? Each bar counts up the number of observations, except that the categories are already determined for us, right? Because they'll be part of the variable. So if we create a bar graph of the species variable, then we know there were 3 species, And sure enough, we see those on the x-axis of this graph, and each bar corresponds to how many hawks of that species were in this data set.